Alright, let's move to the set number 3, question number 11 to 15. Hitesh and Shanto has 600 marbles. He put them in 5 different bags, each containing 120 marbles. The marbles were of different colors, purple, red and blue. It is also known that number of purple marbles makes a geometric progression with a common ratio between 1 and 2. R is between 1 and 2. Definitely a fraction, right? Number of marbles, red marbles is a distinct prime number. Number of blue marbles is a 2-digit numbers, belongs to this series Fibonacci sequence 0, 1, 1, 2, 3, 5. Fibonacci sequence is from third term onwards. Every term is equal to the sum of the previous 2 terms, right? Each bag had marble of all 3 colors. The total number of marbles of each color was between 175 and 215, both not included. Okay, let's start with the first statement. The number of red marbles in the bag makes a geometric progression with a common ratio which is between 1 and 2. Think on this. Let's say the smallest number of purple marbles is A. And so next will be AR. Next will be AR square, AR cube, and A asked for 4. R is definitely a fraction, right? So let's say R is in the form of x upon y. So now this term will be what? A into x raised to the power 4 upon y raised to the power 4. Every term must be integer, right? So for this to be integer, A must be a multiple of y raised to the power 4. A must be a multiple of number raised to the power 4. Alright. So the smallest such number can be what? 2 raised to the power 4, 16. Correct. That means if this is 16, 16 into this is an integer. So this should be cancelled with this one. So definitely y has to be 2. So that 16, 16 will be cancelled out. Correct. So basically what I am saying is that this number is A into or 16 into x upon 2 raised to the power 4. Correct. Also, because r is between 1 and 2, so if x upon 2 is between 1 and 2, x can be what? It cannot be 1, it cannot be 2, it can be 3, it cannot be 4, it cannot be 5, because otherwise it will not between 1 and 2. So can I say definitely r is 3 by 2. If r is 3 by 2, A is 16, AR is 24, then 36, then 54, then 81. Okay. The basic idea is that the smallest number, or you can see that largest number also, is in the form of A raised to the power 4. Now anyways, see, what we have taken smallest number is because A is between 1 and 2, it's an increasing GP, right? Otherwise, if you talk about generally that any increasing GP can be written as decreasing GP also in reverse order. So that does not make a difference. Here, the order does not satisfy, does not clear, right, about the number of bags. I mean, in bag 1, 2, 3, 4, 5, what are the numbers, right? So I'm not sure about that. But the question does not follow that also, right? So that means I can put any number of, I mean, to fix one of the thing, I can fix purple marbles in the different bags. So let's name them 1, 2, 3, 4, 5. So if I simply put that as 16, 24, 36, 54 and 81, and according to that I'll satisfy the other condition, that's okay. Okay? Because in the question, names of the bags does not give you anything, right? It is not necessarily needed. Alright. Also, this is the smallest number. Okay. The question also says that total number of marbles are between 175 to 215. If you add this, this will give you 211. Alright. So obviously, if you take any other number which is of the form like 3 is power 4. It's clearly ruled out because the sum will be definitely more than 215, okay, for the increasing GP. I mean, we are talking about smallest number again, right? Also, you can see that this is the 3 is power 4 type of number, correct? But in that case, it will become a decreasing GP, and the common ratio will not be between 1 and 2. Okay, so we have fixed this. Second thing, if we talk about blue marbles, the number of marbles are from 0, 1, 1, 2, 2 plus 1 is 3, 3 plus 2 is 5, 8, 13, 21, 34, 55, 89. That's it. After that will be a 3-digit number. And I need 2-digit number, distinct 5 numbers, right? So how many 2-digit numbers are there? This. Got it. So definitely we need 5 numbers. We have only 5 numbers. So these are the number of blue marbles. Clear? All right. Now if you also, to get these numbers, first I need to subtract this from this, right? This from this, and so on and so forth, so that you actually get a better idea that what is happening, right? So what I'm saying is that after this you can subtract. I mean, this is something we have discussed earlier. Okay, one point here is that without going further, you can solve one of the question at this point of time also. So if you look at question number 13, median of the blue marbles, something like that, right? So we already have the 5 numbers of blue marbles, right? So median is what, 34. So look for such kind of questions when you are left with only 4, 5, 6 minutes and you do not have time to solve one particular set, complete set. Look for such kind of question. It might be possible you might get one of the question which does not require much calculation or much thought process. Okay. So as you can see here, you can solve this question without going further. Alright, moving on. If you subtract these numbers from 120, you will get this left, right? Now, blue marble must be from these numbers, right? And the leftover part should be a prime number. So look for that. Always look for the smaller number first of all. 39 if you want sum. So if you take 13, the remaining is 26, not a prime number. If you take 21, remaining is 18, not a prime number. 34 gives you 5, prime number. These are definitely more than 39, so not possible. So can I say that only possibility is 5 and 34? Right? So this is done. 34 is used. Always check for smaller and largest, smallest and largest always. Okay. So first of all, second we will check for 104. For 104, if I take 13, so I'm left with the 91, not a prime number. 21, I'm left with 83 is a prime number. Possibility hai. If I take 55, I'm left with 49, not a prime number. If I take 89, I'm left with 15, not a prime number. Again, only one possibility, that 83 is here, 21 is here. 21 is also out. 2 number fixed, right? Check for 66. If I take 13, I'm left with the 53 is a prime number. So this is one of the possibilities. Sorry, reverse. If I take 55, leftover is 11, again a prime number. So this is also a possibility. '84. If I take 13, I'm left with 79. '84, right? Sorry. I'm left with 71. Again a prime number. So 13 and 17 is possible. 71. If I take 55, I'm left with 29. This is another possibilities. Clear? So we do not have any concrete value as of now for these two values. Now one thing is for sure, that if 13 is here, 55 will be here, or 55 is here, 13 is here. So 13 and 55 will definitely follow these two cells. So it cannot be used in 2. So the only number left with us is 89. And for that, to get 96 sum, this has to be 7, which is a prime number, so satisfied. Now one case will be with this and the other case will be this. 2 cases, right? Not 4 cases, because one of them will follow the other, correct? So this is how we can make 2 cases. One with 71, 13, 11, 55. One with 29, 55, 53 and 30. Now we can solve the question. What is the possible number of arrangement combination possible? Answer is 2, right? What is the maximum possible number of blue marbles in the 5 bags? Blue marble, in either ways, in both cases we have same number of blue marbles, that is 212, which is your answer. Which of the following is the median of the, this is that question I am talking about, right? Number of blue marbles, median 34, without solving much further, right? Total number of purple marbles in the bags. Enter 99 if the answer is cannot be determined. It's a theta question, right? So we have discussed this in Telegram channel also, that one of the student asked that what should be done in this case. So generally in a theta question, answer and cannot be determined is not an answer, right? If it is there, extreme case, then such kind of statement will be there, that if answer is CBD, enter some number, could be 99, could be anything, okay? But here we have fixed value, right? Purple marble, in both cases we have same, we have 211. Alright, 15. Hitesh asked Shanto to determine the number of purple, red, blue marbles in each of the 5 bags with the help of the given information. For how many of these 5 bags can Shanto uniquely determine the number of marbles in the 3 colors present in them? So we have fixed with 1, 2 and 5. So for 3 bags I can uniquely determine the number of marbles of different colors, and that's your answer. I hope it is clear. Good.